Okay, hello everybody. I'm here today because I wanted to talk to you a little bit about your research investigation. If you're in year 11, that's your FA3 or Formative Assessment 3. And if you're in year 12, it is your IA3. Now, regardless of which year you're in, this assessment is worth 20% of your final result. And so it's worth taking it seriously. Conditions in year 11 and 12 are exactly the same for this one. Obviously, it will be a different unit and different topic, but you will all be given 10 hours of class time. The mode or the response needs to be a written scientific essay of no more than 2,000 words. Please do not go over 2,000 words. It's really important that you stay within the word limit, because if your work gets sent off to confirmation and it is over 2,000 words, they will not allow your grade to go through. So you must stick under 2,000 words. You'll get 10 hours of class time at a minimum. It's likely we'll probably give you a little bit more, but we'll make sure that every class gets exactly the same amount of time. What you need to do, it's a little bit like a student experiment in terms of how you analyse the data, the only difference being that you're using someone else's data instead of your own. So you'll be given a series of claims by Dr. Thomas and myself. You'll choose one of those claims, figure out what that claim means or what the relevant chemical concepts are that are associated with that claim, and use those concepts to pose a research question. Okay. And that research question has to be linked to some aspect of the claim. It doesn't have to be linked to all parts of the claim, but it does have to be quite specific. And the reason we do that is because the claim is quite broad. And if you try and write to the claim, there's no way you could do it in 2,000 words. So you have to refine your research question down to something that is reasonable to answer in the 2,000 words. Okay. The next thing you have to do once you have a research question is to go and find data to support your question. That, I think, is probably the hardest part of this task. Finding valid experimental data that supports or negates your research question is difficult. And I would strongly recommend that before you finalize your research question, you have a bit of a look out there and see what data is available. Because if you can't find at least 3 really good sources of information, okay, and ideally we're looking for quantitative data, so we're looking for graphs and data tables and statistics. You can do it with qualitative data, but it is much harder. So I would strongly suggest looking for quantitative data and making sure you can find at least 3 really good sources before you finalize your research question. If you can't find really good sources, then change your research question. It's much easier to change your research question than it is to spend weeks looking for data that may or may not exist. Once you have your data, you have to go through each data set individually, analyze it for any trends, patterns, relationships, things like that. Look for limitations in the data. Interpret the data to justify your scientific arguments, so linking back to the chemical concepts, and then form a conclusion to your research question based on your data. After you do that, you need to discuss the quality of your evidence and then go back to your claim and say, well, based on my research and my research question, the claim is true, not true, or partially true. Okay, it's okay not to be able to fully answer the claim from your research question, because your research question won't address all aspects of the claim. Okay, after that, you make some suggested improvements and extensions. So what I wanted to talk to you about now is the ISMG, the Instrument Specific Marking Guide, and just the first section. I'll make separate videos for the other sections so that you don't have to listen to my voice for extended periods of time. But the first section of the criteria sheet is all about research and planning. Okay, and all the marks for this come basically from your rationale and your research question. So the top point, informed application of understanding of, now this will change whether you're in year 11 or 12, but it'll be the chemical concepts that we're looking at. The important bit is this: demonstrated by a considered rationale identifying clear development of the research question from the claim. So we need to see exactly how you came up with your research question. We need to see that you've taken that claim, you've broken it down into the main key terms in the claim, you've investigated those key terms and what the chemistry is behind those key terms, and you've shown how you got from that claim to your question, which will probably mean that you show an original question and then further refine it down till you get to your research question. Okay, so your rationale needs to have the relevant chemical concepts. It needs to have that claim broken down into pieces and a research question clearly developed from the pieces of that claim. The other 2 dot points in this criteria, effective and efficient investigation of phenomena associated with, again, it'll be the content linked to your particular topic. But what's important again is this bit demonstrated by a specific and relevant research question. Now, I know I said this with the student experiments and I'll say it again now. I'm pretty sure everybody will be relevant because you're going to pick a topic that's related to your claim. We're not going to have a claim about plastics and then you go and write a research question about reaction rates. Your topic is going to be relevant. So the issue is whether or not it's specific. And if it's specific, it means there is no confusion about what you're going to investigate. So you won't just say, are plastics good? What do you mean by good? What factors are you going to investigate? What are the specific criteria that you will make your judgments on? Okay, you won't just say plastics. You'll tell me exactly which plastic you're looking at or which plastics you're comparing. Make sure your question is specific so the reader knows exactly what's going to follow. And then the last one, a selection of sufficient and relevant sources. I would strongly recommend you have at least 3 sets of data or 3 pieces of information that you are going to analyze. You might have more than that, but I would say that a minimum of 3 will get you the sufficient and hopefully they're relevant to your question sources. Okay, if you can do those 3 things, you'll get a 6. If you get 2 dots, let's say you get a specific and relevant question and you've got plenty of sources, but I don't see clear development of your research question, I only see that it's sort of linked to your claim, then you would get a 5 instead of a 6. Okay, I will be back with videos for the other parts of the criteria, but I hope that this has helped you with that first section. Goodbye.